Hello everyone. Let me introduce myself. I'm Dr. P. Deepamangai, working as an assistant professor in the Department of EEE, SRM Madurai College for Engineering and Technology. In this video, we are going to discuss about the mesh analysis. It is a main topic in circuit analysis, electric circuit analysis. First of all, what is mesh analysis? It is defined as a technique for calculating the currents in the loops of a planar electric circuit. It is also known as mesh current method. The planar circuit means it is only applicable to circuits that can be drawn on a plane without crossing connections. So it is working based on the principle of Kirchhoff's voltage law. It states that sum of the all voltages around any closed loop is zero. The major advantage of mesh analysis is it simplifies the analysis of complex circuits into manageable equations. So the basic procedures involved in the mesh analysis is, first step is to count the meshes, identify the number of independent loops, let it be n, and define mesh currents. Assign a current direction to each mesh, that is I1, I2, I3, and apply KVL with the KVL equations for each mesh, and then solve the equations using methods like determinants or matrix operations to find the mesh currents. So let's see an example. This is the example we have taken. Here the steps involved is, first we have to apply KVL for each loop. Make the assumed direction of each mesh current, assign voltage polarities for each component, and set up the KVL equations considering shared resistors and overlapping currents. So the first loop, in this loop the current is considered as I1. Here we have to write the KVL equations. So in the loop the voltage source is E1. So E1 minus V1 minus V3 equal to 0. We have assumed the direction of current in the clockwise direction. So E1 is plus 2 volt and V1 is the voltage across the resistor 2 ohm and V3 is the voltage across the resistor R3, that is 4 ohm. So V1, the voltage across the resistor 2 ohm is 2 into I1, since the current flow through the resistor R1 is I1, and the voltage drop across the 4 ohm resistor is 4 ohm into I1 minus I2, since the R3 is the branch which is common to both the mesh I1 1 and 2, that is both the loop. So total current through the resistor R3 is I1 minus I2. So by solving this equation we get 6I1 minus 4I2 equal to I2. Similarly, we have to apply the KVL for next loop. That is, here the voltage source is E2. The current assumption of the current direction is also in the clockwise direction. So, minus V3 minus V2 minus E2 equal to 0. So, V3 is again the voltage drop across the resistor R3 and V2 is the voltage drop across the resistor R2. So, 4 ohm into I2 minus I1, since here we consider the loop 2. So, the polarity of the current is I2 minus I1. If we consider the loop 1, the current is I1 minus I2. If we consider the loop 2, it is I2 minus I1. And the voltage drop across the resistor 1 ohm is 1 into I2. Since the current flow through the resistor R2 is I2 and the E2 voltage is 6 volt. So by solving the equations we get the equation of minus 4I1 plus 5I2 equal to minus 6. So we have two linear equations. So these simultaneous linear equations can be solved by any methods, matrix method or determinant methods. In this video we are using the determinant methods. First of all we have to calculate the determinant. The loop 1 equation is 6I1 minus 4I2 equal to 2 and loop 2 equation is minus 4I1 plus 5I2 equal to minus 6. So determinant is plus 6, that is the coefficients of I1 and I2. 6 minus 4 plus 5. So 6 into 5 minus of minus 4 into minus 4, so 14. So next we have to find the del 1, that is del 2. Del 1 means we have to replace the first column of the determinant with the 2 and 6, that is the right hand side values. And for del 2 we have to replace the second column with the right hand side values. So the formula by using the determinant method, that is Cramer's rule. It is also known as the Cramer's rule. I1 equal to del I1 by del, that is minus 14 by plus 14 equal to minus 1 amps, and I2 equal to del 2 by del, that is minus 28 by 14, that is equal to minus 2 amps. The minus sign here indicates the actual current direction is opposed to the assumed direction. That is, we have assumed some direction of current, that is I1 and I2, but that current is in opposite direction to the direction what we assumed. So finally we have to calculate the values of I1 and I2. Similarly, this method can also be used to calculate the voltages. So in this video, we have to recap some importance of mesh analysis in circuit analysis, and thank you for their attention. Thank you once again.